standards, fatigue tests were carried out under road control by imposing a sinusoidal waveform and with a low ratio equal to -1. Test frequencies were ranged from 1 to 22 Hz, depending on the applied stress level, in order to maintain the material temperature below 30 Celsius degrees. Temperature was measured by gluing a thermocouple at the notch tip. For the damage evolution, dedicated static and fatigue tests were carried out, and the damage was monitored by using a triangle microscope. Here, just an example of characteristic stress strain curves in the case of obtained in the case of clay material, and here we can see that the elastic modulus was reduced of a factor of about 20% by using completely recycled polypropylene with respect to the compounds made by virgin material. And also a similar decrease was found in the case of heel strength by comparing the heel strength measured in the case of fully recycled polypropylene with respect to the virgin material. The results of static tests carried out on notch specimen are summarized in this table. And keeping in mind that the ratio between the theoretical stress concentration factor evaluated in the case of sharp notch with respect to that evaluated in the case of blank notch is equal to 3.6, we can see here that the compound made by virgin polypropylene, the ratio between the heel strength evaluated in the case of blank notch with respect to the heel strength evaluated in the case of sharp notch is equal to 1.0. Similarly, in the case of partially recycled polypropylene, we can see that the same ratio is equal to 1.1. And finally, also in the case of totally recycled polypropylene, we can see that the same ratio is equal to 1.12. Therefore, at least from an engineering point of view, we can conclude that all tested materials resulted practically insensitive to notches under static loads. Just an example here of damage evolution, we monitored the damage evolution from two different positions, a lateral view in order to see what happens inside the notch, and from front view in order to see what happens in the next section. Here we can see an example obtained in the case of totally recycled polypropylene and notch root radius equal to 10 millimeters. Here we are seeing the specimen from lateral view, therefore here we are inside the notch. We can see that damage evolution starts with several voids that grow, and some of them coalesce to form a single void that becomes very large at the end of the static test. And here we can see that the light is coming from the opposite side because the void is completely developed in the width of the specimen. Otherwise, if we observe the specimen from the front view, we can see that the final crack is not completely propagated yet in the next section. We have performed this type of analysis for all the materials, for all notch radius, and we can conclude that damage mechanism and their evolution were independent of the type of material and notch radius. They consisted of void formation and coalescence. Now I'm moving from fatigue test to fatigue test results. Here we can see the fatigue test results obtained in the case of virgin compound made by virgin polypropylene. All the fatigue data can be summarized in a single scatter band in terms of stress amplitude to refer to the next section, despite of the different notch severity. Therefore, we can conclude that the material is notch insensitive, with a reference fatigue strength evaluated at 2 million cycles and 50% survival probability equal to 10.5 megapascal, and an inverse slope of fatigue curve equal to 12. Similar results also in the case of partially recycled polypropylene. We can see that also in this case all the fatigue data can be collected together in a single scatter band. Therefore, also these compounds can be considered as notch insensitive, with a fatigue strength evaluated at 2 million cycles equal to 10.6 megapascal and an inverse slope equal to about 14. Therefore, we have decided to analyze both the compounds as a single population from a statistical point of view, and we found a single scatter band having a fatigue strength, reference fatigue strength evaluated at 2 million cycles equal to 10.5 megapascal and 50% survival probability. We can see here that in the low cycle fatigue zone, the yield strength of material is practically equal to the fatigue strength of material is practically equal to the yield strength of the material. In the case of totally recycled compound, we can see that also in this case we can draw a single scatter band in terms of applied stress ambient to refer to the net section. Therefore, also this compound can be considered as notch insensitive, but with a different and lower fatigue strength, having a 50% survival probability, referred at 2 million cycles, equal to 8.4 megapascal, and a different slope of the fatigue curve. The low cycle fatigue zone is characterized by a fatigue strength that is practically equal to the yield strength of material. Therefore, we propose two different fatigue design curves. Here, I will show you the fatigue curves at 50% of probable survivability that I showed you before for both these compounds. And then we have calculated the fatigue curve at 90% of survival probability, having a fatigue strength calculated at 2 million cycles equal to 9 megapascal, and we have cut the low cycle fatigue zone by with the fatigue strength evaluated at 1000 cycles. Similarly, in the case of totally recycled polypropylene, this is the 90% survival probability fatigue curve that was downgraded in also to calculate with aim to calculate the reference fatigue strength at 90% survival probability and 2 million cycles, that is equal to 7 megapascal. And then we have cut the low cycle fatigue zone with a reference fatigue strength evaluated at 100 cycles, that it was equal to 13 megapascal. Therefore, two different fatigue curves were proposed. One for compound made by virgin polypropylene, and the same curve for partially recycled polypropylene, but a different fatigue curve that is downgraded with respect to the red one for totally recycled polypropylene. Just an example of damage evolution observed in the case of fatigue load. Here we can see the specimen thickness, therefore we are seeing the specimen from lateral view. Here we are inside the notch. In the case of totally recycled polypropylene and high cycle fatigue. This is the initial condition and the image material. Here we can see the damage that is characterized by material whitening, as you can find literature, at 45% of total fatigue life. This whitening grows in the thickness direction. Here this picture is taken at 62% of fatigue life, and we can see here that 67% of total fatigue life, formation of some elongated voids in the thickness direction that propagate at 80% of total fatigue life. And here we can see that we found practically a single big void completely developed in the thickness direction at 96% of the total fatigue life. But if we observe the specimen from the surface, we can see that we can see only a material whitening without any cracks appearing in the specimen surface. This type of analysis was carried out for all the compounds of the notch geometry investigated in this paper, and we can conclude that in the case of fatigue loading, damage mechanisms, the evolution were independent of the type of material and notch radius. As in the case of static load, this mechanism consisted of void formation and coalescence. Just an example of a characteristic fracture surface. This is the fracture surface of the same specimens. And we can see here the gray zone where the crack propagated from both the notches, and the white zone is where the static failure happens at the end of the fatigue test. Therefore, to conclude, Concerning the static behavior, it was found that the heat stress decreases of about 20% by using fully recycled polypropylene compound with respect to the original polypropylene compound. All tested material resulted practically insensitive to notching in static tests. These results was also confirmed in the case of fatigue load from low cycle to high cycle fatigue regime. And finally, it was found that static damage mechanism and the evolution were independent of the type of material and notch radius. They consisted of void formation and coalescence, and the same mechanisms were observed also in the case of fatigue behavior. Thank you very much for your attention.